Please welcome MarkLogic's Senior Vice President of Engineering, David Gorbet.
Acme Insurance, this is Miguel speaking. How can I help you?
Hello, this is Rick Judd here. I have a policy with you guys, and with the new GDPR regulation, I wanted to know what personal information you have about me, and I guess more importantly, how you use it.
Okay, let me see what I can find. Hold on a second.
GDPR, so the General Data Protection Regulation. It's a new European privacy law with global impact. So GDPR covers over 740 million people. That's 10% of the world population. So every organization, everywhere, who serves European customers needs to think about how to comply. And the fines for non-compliance are huge, up to 4% of revenue. GDPR gives people an unprecedented level of control over their data. The law requires you to know what personal data you have, to know how it's being used, and to prove that you have consent for that use. Anyone who's ever done any kind of IT project knows how hard this is to do. Data is everywhere in your organization. To comply, you need to know not only where it is, but who it belongs to and what it's being used for. You need to track metadata that tracks consent, and you have to be able to audit this over time. And remember, consent is use-based. You can consent to one use, but not to another. And consent is temporal. It can be granted and revoked, then re-granted and re-revoked at any time. And you have to prove that you had consent when you used the data, regardless of whether or not you have consent today. But even with all that, you cannot comply with GDPR just by tracking things and reporting things. You have to bring all of this into your operations so that you can honor consent when the data is used. So in other words, you have to ensure day to day that you're not using data if you don't have consent for that use. GDPR is the most complex regulation the European Union has ever produced. It's 4 to 5 times more complex than existing law. And it's also probably the most complex IT project that you're ever likely to undertake. It's master data management, enterprise application integration, entitlements management, and regulatory reporting all rolled into one. Any one of these typically takes years to complete, and 68% of all IT projects fail. In fact, 1 in 6 large IT projects fail so badly that they threaten the very existence of their organization. That's not good odds. So, GDPR takes effect in 16 days. I'm not going to ask any of you how many of you are ready for it. I'm just going to say that if you know someone who needs help with that, you should refer them to your friendly MarkLogic person, because we can still help. So, by now, those of you who don't run global IT infrastructures that serve European customers are probably breathing a sigh of relief, right? Well, if you think this doesn't apply to you, think again. Because right here in California, the California Consumer Privacy Act is on its way. And after the Facebook, Cambridge Analytica thing, I think it's fair to say that we should all be preparing ourselves for more of this kind of thing. So, what does Miguel need right now? He needs a unified, actionable 360 view of data. You've all seen this slide before. You've all heard me talk about it before, but I want to stress the word actionable here, because this poor guy is on the phone with a customer, and he needs an answer to this question right now. So, what do we mean when we say actionable 360 view? What do we mean by operational data hub? It means you can use it not just to observe the business, but also to run the business. So let's dig into that a little bit. So at a high level, there's this thing called the business. Its mission is to convert inputs into value. And it does this with a whole bunch of business processes. And then it looks at how well it's doing, and it uses that information to try to improve. So this part here is observe the business. And this part here is run the business. Observe the business is not usually real time, right? It's usually end of period reporting is good enough, and it's usually aggregate calculations, like what were our sales in the Eastern region last quarter? And these are pretty static over time because you want to compare these to observations from the same quarter last year or the year before that. Run the business is real time. It happens in the context of a process that needs to complete efficiently. And it's about something specific. It's not about total sales in the Eastern region. It's about this particular sale I'm making right now. Is it priced right? Who's the customer? Is the transaction potentially fraudulent? These kinds of things are subject to frequent change because you're always trying to optimize them to make them more efficient. So observe the business queries are traditionally done, as Ken said, with a data warehouse and data mart architecture. So the old way of doing this is with point integrations from source systems, systems of record, through ETL into the data warehouse. In this model, you have to think carefully in advance of all the questions that you want your data warehouse to answer so that you can model the warehouse schema so that it can answer those questions. And if you don't, then if you get it wrong or if a new requirement gets added, then your warehouse won't help you. For example, a well-known healthcare company created a data warehouse that combines data from over 60 different operational systems to build their pricing models. When they mapped the data from the source systems to the data warehouse, they combined 12 different possible relationships between people, things like child, spouse, grandparent, into just the 3 they needed: spouse, insured, and other dependent. So this worked great for the actuaries, and actually they didn't even mind that it takes over 2 months to get data from some of the systems of record into the warehouse. The project was considered a success. All right, so fast forward a year or so, and now that same company has a new regulatory requirement, reporting requirement. But this requirement has them summarizing data into 8 different relationship categories. It sure would be nice if they could use their big, spiffy, and very expensive data warehouse for this. But sadly, because of the implementation decisions that they made for the actuaries, that data is not fit for this purpose. Besides, waiting 2 months to report would miss their reporting deadlines. So the reporting is another completely separate multi-year project. So the point is that this traditional architecture with point system ETL to a warehouse is just not agile enough. And that's led many enterprise architects to look at a new architecture that looks more like this. So here you see a data lake inserted between the source systems and the downstream data warehouse. And this makes it much easier to land data because a data lake can ingest data as is. And the next step in this architecture is a relational operational data store. So the problem here is that the ODS also uses a predefined schema. So there's still a mismatch between what's in the data lake and what can be put into the ODS. So most of these architectures have a magical transformation layer, and this is where they start to get themselves into trouble, because it's just as hard to build this transformation layer as it is to build the traditional 60 source ETL. But worse, the data in this lake is completely ungoverned, meaning it has no real security model. It's hard to even understand what's in there, and it's nearly impossible to trace the provenance of data from the ODS back through all that ETL, through the data lake, all the way to the source systems. So let's look at one more architecture. This is the one that's most commonly used when data has to move through fast, so for those operational use cases. And I'll use an example from the financial industry. There's a financial industry regulation called MiFID II that requires reporting to regulators within minutes of a trade being posted. And the data comes from at least 3 different source systems. Now, this is way too fast for the traditional data warehouse architecture. So the typical IT response to this is to build a special purpose MiFID II app, and then to ETL data from those sources into that app. The database schema for the MiFID II app is designed to produce the kinds of reports that the regulator needs, and it only uses the 33 trade attributes that are needed for MiFID II compliance from that system. But partway through the project, the business decides to change the requirements. That never happens. They don't want to report directly to the regulator. They want to use a third party, right, to publish those results to the regulator instead. And the third party needs a different format. So the schema in the app needs tweaking. And that means the ETL needs a rewrite. So, okay, they managed to do that. Now, of course, you don't want to report something to a regulator that you can't see yourself, so the next step is to build an internal MiFID II compliance dashboard that runs on that data. All right, so now IT can declare success, change gears, focus on the next regulation. It also needs data from some of these systems, along with other systems. And it needs more than 33 attributes. It sure would be great if they could use the ETL they already built for the MiFID II app, but sadly, that ETL has baked in fit-for-purpose assumptions around MiFID II reporting. So they start from scratch with a new app, a new ETL. Of course, now the dashboard is more complicated because it needs to source data from two schemas instead of one. So they throw a new database under the dashboard, then the ETL data into that. You can see that this architecture gets more and more complicated with more use cases. What happens when the next regulatory app comes along? But worse, the data is now spread all over the place, and it's been transformed at each step. So it's not just copies, it's slightly different data modified to be fit for purpose for multiple different use cases. It's hard to tell when there are inconsistencies, whether that's bad data or whether it's just good data used in the wrong way. If something looks suspicious, it's almost impossible to trace it back through all those transformations to the source to understand why your data looks the way it does. And this architecture quickly becomes completely unmanageable. And unlike what Gary said yesterday about the value increasing as you add new use cases to a MarkLogic hub, here the cost increases with new use cases. So with options like these, it's no wonder that 60% of companies say they are not ready for GDPR. And frankly, some of the other 40% are deluding themselves because in a recent survey, 87% of CIOs believe their current state leaves them exposed to risk under GDPR, and over half believe their companies will be fined. Because despite what regulators may think, this stuff is not easy. It's hard to design and build huge Uber schemas that can answer any question that a regulator may throw at them. It's hard to design and implement complex ETL to move data from source systems into those schemas. It's hard to connect all your business processes to them through large-scale enterprise application integration projects. It's hard to do the things you need to do to comply with operational data integration requirements like GDPR. So let's get back to the story and let's see what happens next.
Thanks for holding. I have your record here and can tell you exactly what personal information we have and how we use it. If you'd like to update your consent as well, I can do that for you right now.
That would be marvelous. I'd also like to verify the accuracy of my data as well.
Great, we can do that too. I need to let you know that GDPR requires proof of consent, so I'll need to record this conversation to document your request.
Okay, lucky for Acme, they're not saddled with these legacy architectures. They have an actionable 360 view of their customers that works for GDPR. And in a few minutes, we're going to look at the architecture of their system and compare it with these legacy architectures. But first, let's walk through a few principles that are important when you're building systems like these. So 2 years ago, I spent a lot of time on the stage explaining a fundamental flaw in the relational model for data integration, the fact that you need to design a schema for the integrated data before you can do any of the integration work. For this schema design step, you have to know upfront all the uses of your integrated data. This takes a lot of time and is really hard to figure out in today's world where things are constantly changing. Also, there's always cross-organization collaboration and prioritization for this. So that means cross-organization politics. And this, more than anything else, kills these kinds of projects, usually by preventing them from starting in the first place. But even if you can figure this out, these predefined use cases end up being hard-coded in the schema and the ETL, making the integrated data fit for that purpose only, just like that healthcare company, or with their actuarial enterprise data warehouse. So you have no agility. Even if you succeed, against all odds, at best, what you do is create another data silo. And finally, we have those provenance, lineage, and general data governance problems that I mentioned earlier. So last year, I talked about the critical importance of governing your data well, and I defined governance as the application of your policy to your data. With the traditional approach, it's hard to tell where the data came from. Who transformed it, when, why, and how. And because the data flows through so many different technologies, you can't attach the metadata that you need to ensure that it's managed in accordance with your policy. So the key principles for a successful data integration architecture follow directly from these three limitations. First, you can't spend years working across your whole organization figuring out all the use cases for your integrated data and dealing with the politics of who's going to cost share on this project and how are you going to prioritize across all these organizations. In fact, you shouldn't even be thinking about it from the data perspective in the first place. You want to start from the business process that you want to enable. What is the critical business need that requires integrated data? For our call center guy, maybe it's the ability to find a customer, to get his personal information and see its uses and the consent that's been given, and the ability to update that consent. So our guy is going to use a nice UI for this, but that UI is fed through application programming interfaces, APIs. It's easy to build the UI if the exact APIs it needs are already there. So what are the magic data service APIs that if you only had them would make satisfying the business need easy? APIs like find customer, get personal info, update consent. These are business-level APIs defined in the language of the business. They're independent of the way the data is modeled or stored. So thinking first about the way the data is going to be delivered allows you to focus on the business value that you need to create without getting distracted by some boil the ocean project to integrate all customer data for all potential use cases. It helps you scope what data is actually needed for you to integrate and just how integrated it needs to be to solve the problem. So you get much faster time to value. So we call this principle of starting with how you're going to deliver the integrated data API first. Now, once you've delivered the business value that you need for that first use case, you'll want to extend that value to the next use case. So for example, my GDPR hub can now help our call center guy here have this conversation with his customer. But can it help Acme honor the consent in their operational processes? So how are those operational processes going to learn whether they can or cannot use this customer's data for their specific use? They can't use the Get Personal Info API because Get Personal Info returns the info for a specific individual. But the operational process in this case needs all the email addresses for all customers who meet a certain profile so that it can conduct a marketing campaign. It needs a Get Customer Emails API that searches for customers that match certain criteria and then returns the list of emails to use in the mailing. And some of those criteria used in searching need claims data in addition to customer data. So all this leads to the next important principle: expect and embrace change. If you're going to prioritize the most important business problem at the expense of other use cases, at some point, you're going to have to come back and implement those next level down priorities. And at some point, you're going to come up with a new use case, or you're going to generate a new data source that also has to be integrated. Change is inevitable. An agile data hub turns change into opportunity instead of risk. So this principle of embracing change is already there in all of your IT shops. It's called agile software development. You're probably already agile in most of your IT, but traditional technology has made it really hard to bring the benefits of agile development to your data integration projects. An agile infrastructure that expects and embraces change enables your agile development and lets you respond to change at the speed of the business. So now you've implemented the new Get Customer Email List API. Where is consent managed? Do you return a list of emails along with which ones can and can't be used and then leave it up to the marketing automation application to honor that consent? Or do you implement the consent rules in the data hub itself? So the new Get Customer Emails API doesn't even return customers who haven't consented to that use. Of course, you implement the policy in the hub. Why? Because doing this in the hub gives you one point of accountability for understanding the policy and translating that into rules that implement the policy. Otherwise, you leave it to hundreds or even thousands of application developers to understand and interpret your policy for you, and then embed it in their code. Doing this in the hub gives you one place to audit compliance with the policy. Otherwise, you have to look at everyone's code and see if it's sufficient to implement your policy. And doing this in the hub gives you one place to effect changes to the policy. So if tomorrow a new piece of data is subject to PII, you can tell your hub once, and then all applications using that hub will automatically adhere to the new rules without having to change a single line of code. So the point here is that agility is not limited to sources or uses of data. It also has to apply to policy on that data. In the financial industry, major banks are subject to upwards of 200 rule changes every single day. You need to be agile to adapt in an environment like this. You can't just educate thousands of developers about all the rules that apply to them and just hope they're going to get it right. Which leads me to the third principle, governed by default. This means that the onus should not be on consumers of the data hub to govern the data correctly. It should come out of the hub governed by default. What does governed mean? It means all the things I talked about last year: data quality, fit for purpose, provable provenance and lineage, security and privacy, compliance, lifecycle management, availability, and any other policy you need to apply to your data. Governed by default means that the policy is attached to the data so that it comes out of the data hub with the policy attached. And adherence to the policy by consumers of the data can be either easy or automatic. So here's what Acme's data integration architecture looks like. This is the MarkLogic data integration architecture. At first glance, it looks pretty familiar to anyone who's seen the big data architecture that I mentioned earlier. It has a place for data to land as is. It has a curation process that prepares the data for operational use. And it has a place for data to be served up to operational or analytics workloads. If you squint a bit, that as-is store may look a little bit like a data lake. And that curated store may look like a relational ODS. But don't squint too hard, because there are important differences between this architecture and the more cobbled together one that I showed earlier. And so I'm going to go through those. First, this architecture has one technology behind it. Because of its unique capabilities, MarkLogic manages all the data on both sides of the curation process. And because it's MarkLogic, you get transactional updates with guaranteed consistency, ACID compliance, temporal management, high availability, disaster recovery, full indexing and real-time query with a strong and consistent security model on both the as-is side and on the curated side. You also get huge visibility, traceability, and governance benefits because all of these curation activities happen in the database, where activity is tracked and auditable provenance and lineage metadata is stored and managed right alongside the data. And you don't have to invent a magical transformation layer to do the curation. All this curation activity is orchestrated for you by the MarkLogic Data Hub framework. So many of you are already using the Data Hub framework. You can put your hands up if you're using it. Who's using the Data Hub framework? All right. And in its community-supported form. And I'm happy to talk about the Data Hub framework now comes pre-packaged with the latest release of MarkLogic and is fully supported as part of the product. And we're going to continue to deliver frequent updates to the Data Hub framework, starting today with DHF 3.0 and continuing this summer with new capabilities in DHF 3.1. So what are these curation activities? What's involved in curating data to make it usable? Here are some of the common activities involved in taking data from the source systems and then curating it into integrated data that's ready to use. These are similar to things that you're already doing with your data, but in the legacy relational architectures, all these things are done outside the database in batch operations that are hard to trace. In the MarkLogic Data Hub, these things are not prerequisites to getting data into your hub, but features and benefits offered by the hub itself. So let me just call out a few of them to illustrate why our approach of doing this in the database is better than the legacy approach. So first, validation. I talked about validation last year, how the relational world is chasing that single golden record that's valid for all use cases. But the real world isn't like that. In real life, different validation rules apply for different use cases. With MarkLogic, you can define flexible and fluid validation rules that execute inside the database. You can choose to reject invalid data, or you can accept it. You can choose to flag it so it doesn't get used in the wrong way. You can choose to make it available for some use cases, but not for others, or for some people and not for other people. Instead of a single golden record model, where you have to come up with one and only one definition of data quality, you have a fit-for-purpose model, where data that's acceptable for one purpose can be rejected for another. Harmonization is the process of translating from idiomatic source data models into a canonical model that can be repurposed to serve multiple use cases. In a legacy architecture, this is typically done in ETL before you can even load data into the database. Now, I could expand an entire keynote on why this in-database harmonization is better than the traditional ETL approach. And in fact, I did that 2 years ago. For now, suffice it to say that our harmonization approach lets you build and modify your canonical model in an agile way, doing only the work that's needed to meet your business goals without painting you into a corner for future use cases. It also lets you isolate changes to upstream systems or to the data hub itself from downstream systems and business processes, which makes implementation easier, faster, and more successful. Now, if you're going to integrate data from multiple sources, you will at some point need to deal with matching, merging, and deduplicating records. For example, the same customer may exist in more than one source system. You need to be able to match those records up and merge them into one customer record. This mastering capability traditionally happens outside the database using a master data management or MDM technology. But just like validation, MDM assumes that there's one right answer and that you can somehow produce a golden record that can be used in all use cases. Worse, when you merge records, survivorship decisions like which spelling to use for a first name have to be made before data enters the database. And once they're made, these decisions and their alternatives are both untraceable and irreversible. With MarkLogic's smart mastering feature, matching, merging, and deduplication happen inside the database where all this activity can be tracked. So let's listen to more of our GDPR conversation and watch Miguel work through this with his customer Rick to understand why that's important.
Mr. Judd, it looks like we actually have 2 different dates of birth for you. Can you please confirm your date of birth so I can be sure it's accurate in our records?
Sure, that would be the 23rd of March, 1980.
Okay, thanks. I'll mark that one as authoritative. Also, we have 2 first names for you. Do you go by Rick or Eric?
Oh, I see what's happened. My name is Richard, but I go by Rick, and my cousin Eric lives with me, so maybe that's the confusion.
Okay, it looks like this record was merged from 2 other records. I can unmerge those so that the system knows that you're 2 different people with similar names who happen to live at the same address.
Okay, there are a few important things going on there. So first, the ability to have more than one value for a property like name or date of birth. When you merge inconsistent records, it's not always clear which one is correct. Traditional MDM uses survivorship rules to determine what to keep and what to throw away. It's much better to be able to mark one as authoritative without removing the others, and you can't do this if you've thrown them away before they get to the database. Then there's this concept of provenance. When you mark something as authoritative, being able to add metadata that tracks who did it, when, and why will help you later when you need to understand how a record got into the state it's in. So Miguel used this provenance data to understand that this record was originally 2 separate records, and when he unmerged them, the act of unmerging also gets recorded, and so does the reason and the context and metadata about the phone call that prompted it, all there to unwind later if you need to have visibility into how your data got into the state that it's in. And finally, there's the unmerge itself. With traditional MDM, records are merged before they hit the database. You can't unmerge because the old data and the history of those records as they existed before is lost in the MDM process. Data quality is an ongoing activity. If you can't see where your data came from, and if you can't update it or correct it if it's wrong, how are you ever going to end up with high quality data? Maybe that's why 76% of MDM projects fail. So now let's talk about relational and semantic views. In a traditional architecture, you model and store your data in one form, and that's how you get it back. But different business processes need data in different forms. They may have different concepts of what valid looks like. They may have different ways of thinking about the same things. They need to see data in the language of their use case, and your data hub should be able to make that translation for them. So let's look at an example. This is an application that we built for a customer to help them assess enterprise-wide risk and prevent accidents. Risk information includes data from lots of places: incidents, loss investigations, change management documents, inspections and maintenance records, risk studies, and safeguards. All this information is tied to specific equipment and business entities, and it all exists in multiple independent data silos, each with their own vocabulary. This company has two different ways of referring to the LA area, but from the risk analyst's perspective, they're equivalent. MarkLogic's semantics capability makes it easy for her lens on the data to treat them as equivalent without having to touch and transform all those records. She can see a map of the concepts used in the data and teach the system that for her use case, LA Basin and LA area are the same. And she can get this view without impacting other use cases that may need a different view. So why can't you solve this problem by cleansing your data before it gets into the data hub? Because although these concepts are equivalent for the risk manager, they may not be equivalent for some other use case. Remember that healthcare company whose actuaries collapsed their 12 operational relationships into just the 3 they needed. From their perspective, this data was high quality. But because they did this, it was not fit for any other purpose. We saw earlier how smart mastering in the database lets you merge and unmerge records. But a data hub should also let you merge and unmerge concepts, even if they apply to many records, to give each business process the view it needs on the data without sacrificing data quality for other current or future use cases. So I want to emphasize this point. The MarkLogic architecture keeps all the critical data management activities where they belong, in the database. That's why you get all the agility, traceability, and governance you need without sacrificing robust, scalable, secure, real-time access to your data. So unlike these legacy architectures where the first use case is expensive and every subsequent use case is even more expensive, as you build out this complex and ungovernable web of data silos, with the MarkLogic architecture, the first use case is cheaper and easier, but even better, every subsequent use case is even faster and easier than the first one because you can leverage the work that you've already done instead of having to start over from scratch. So if there's so much benefit to doing all this curation in the database, then why does the legacy architecture do it all outside the database in a nightmare of ETL and MDM craziness? Why aren't relational DBMSs performing all of your critical data management functions? Because they can't. The bottom line is that your relational database technology has failed you. For 40 years, it's defined data management as just storage and query. But the definition of data management has changed over the last 40 years. It's no longer enough just to store data durably and query it quickly. Managing data today means security, privacy, data sovereignty, lifecycle management, entitlements and consent management. It means flexible validation and different lenses on the same data to ensure fitness for purpose. It means flexible matching, merging, and deduplication with the ability to unmerge if you got it wrong. It means temporal tracking of all this data and metadata, so you know, for example, not just what consent you have now, but what consent you had at the time data was used. It means tracking provenance across all these activities so that you can have full transparency across the data value chain and can see where your data came from and how it got into the state it's in. It means governance and all the things I talked about last year about applying your policy to your data. All these things are critical data management capabilities. You know what traditional relational technology says to this? Not my job. Understanding the business context of your data so that I can secure it appropriately, not my job. Ensuring that data is managed according to its lifecycle policy, not my job. Matching data with metadata so I can know how it can be used and whether it's fit for purpose, not my job. Understanding where your data came from and how it came to look the way it does, definitely not my job. I don't know about you, but I'm sick of hearing from a DBMS that data management is not my job. I mean, hey, Oracle, the M in DBMS stands for management. You say not my job? You know what I say to that? Thank you. Okay, fine. But that means that by today's definition, you are not a DBMS. If all you're doing is storing and retrieving data, if you're not managing it, you are not a DBMS. Oracle, not a DBMS. DB2, not a DBMS. MongoDB, definitely not a DBMS. You should expect more from your database. You should expect it to help you manage your data. But to manage data, to really manage it, you need a smart database. You see, most database technologies just treat your data like a bucket of bits. They can store these bits and they can retrieve them. They can index them. They can execute queries on them, but they have no idea what they actually represent. A smart database understands your data and can map it to key business concepts, which can themselves map to policies and rules about how to manage it. A smart database lets you describe your goals in the language of your business rather than having to translate everything into application code. A smart database knows that this record is a customer and that this property of a customer is personal information, and that personal information is subject to GDPR, and that in your organization, this means you need special permissions to see it, and that consent is required to use it for certain purposes. And a smart database knows whether you have that consent. And the smart database can use that knowledge to decide how and when to serve this data up to your business processes. Remember that Get Customer Emails API? That API should only have access to data for which we have consent. That's a rule driven by our consent management policy. And being able to embed that policy in your MarkLogic Data Hub instead of in hundreds of applications that consume data from the hub is critical to enable correct and consistent policy application, auditability, change management. Today, you can do that. You can embed any policy in your MarkLogic Data Hub because the semantics of the data are stored in machine-readable form inside the database. So you can write, oh, thought I lost my mic there. So you can write code that works in the hub itself alongside the data that can read the semantics of the data and apply the policy. You can do that today because MarkLogic is a smart database. But just like a smart person, a smart database can always get smarter. We introduced entity services in MarkLogic 9 as the foundation for our smart database vision. And MarkLogic 10 will leverage this foundation to extend its ability to understand your data so that you can declare your policy and have the database automatically enforce it. So those of you who were in the security breakout session yesterday, how many of you were in the security breakout session? I can't even see you, so I don't know how many that is. But if you were there, you saw this in action, because you saw Charles did a demo where he told MarkLogic that a property of a customer is PII, and MarkLogic interpreted that policy and applied element-level security to the data automatically. No code required. So this is just one example of the kinds of things a smart database can do, the kinds of things that MarkLogic can do. But you won't have to wait until MarkLogic 10 to leverage this capability. The security capability that Charles demoed yesterday will be available to use this summer, and we'll be releasing new smart database capabilities as they become available. And because entity services is extensible, you can build your own smart database capabilities into MarkLogic as well. So let's hear how our saga ends.
Thanks for calling today, Mr. Judd, and thanks for being an Acme customer. In the future, you can also visit our website where you can log into your account and see all this information and change your consent options from there. Did I answer all your questions and resolve all your issues to your satisfaction today?
Yes, fantastic. It's great to see a US-based company taking privacy so seriously. Many of my European companies I deal with don't seem to be as on the ball with GDPR as you guys. I'm really impressed. Jolly splendid.
Jolly splendid indeed. On the surface, GDPR seems simple. Tell me what you know about me, let me control that. When technology works well, it makes this kind of thing look easy, but it's only easy because Acme Insurance has a smart database. MarkLogic, the world's best database for integrating data from silos. So, thank you. So, a smart database is the product of a lot of smart people. People on my team who plan, design, build, test, document, and support MarkLogic. They're here today, and I want to thank them. I want to thank them for the energy, the devotion, the passion they have. I want to thank them for making the best database technology in the world. They are truly exceptional people doing truly exceptional things, and if you appreciate what they've done as much as I do, you'll want to thank them too. So I'm going to bring one of these smart people up on stage in a minute. He doesn't know I'm doing this, so hopefully he's nearby. So many of you know this person because he's personally worked with a huge number of our customers and partners. He started with MarkLogic in 2005 as MarkLogic's first product manager, and he's made his mark on almost every MarkLogic feature in one way or another. You may know him as the driving force behind our semantics capability. But he also drove most of the search features, the new SQL feature, and our analytics capabilities for many years. Stephen Buxton is retiring this year, and I just wanted to recognize him and give you all the chance to recognize him for how much he's helped us all. So Stephen's passion for MarkLogic, both the product and the company, are evident to anyone who interacts with him. In fact, he's so passionate about MarkLogic that even though he's retired, he's agreed to come back occasionally to lend his experience, his expertise, and his wisdom. In many ways, MarkLogic has always been navigating in uncharted waters. We're a different technology, doing different things in a different and much better way. Stephen has helped us chart this unknown territory and has kept us heading in the right direction for years. In the 18th century, when intrepid explorers set out to explore and map uncharted waters, they used an instrument called a sextant to help chart the course. So Stephen, where are you? All right, come on up on stage. I'd like to present you.
You came along and everything started into hum.
So I'd like to present you with this. Thank you. So I'd like to present you with this sextant. This is just a token of our thanks and a reminder of the trails you blazed and the waters you've navigated to get us to where we are today.
Well, thank you. Thanks, Steve.
All right, Stephen and all the rest of my team are here today for one reason. They're here to learn from another group of really smart people, our customers. Because it's really you, our customers, who are making a difference in your organizations, in your industries, and in the world at large. We provide the tool, but it's you who use that tool to do some truly amazing things. You use MarkLogic to help at-risk children. You're finding more effective ways to treat diseases. You're keeping the wheels of commerce turning. You're saving endangered species. You're helping to feed the hungry, to help the homeless and marginalized, and to educate the world, to provide healthcare for tens of millions of people. Our customers are what keep us motivated and engaged and excited and moving forward to break new ground. And if we deliver, it's because of customers like you. So thank you, thank you, thank you for being customers. So finally, I want to introduce one more really smart person whose life's work has been to explore and examine the market dynamics around disruptive innovations. As an advisor, he's worked with companies from startups to household names to help guide them through their turbulent waters as they entered uncharted territory. As an author, he's responsible for many more startups becoming household names. His thoughts and writing have had a profound impact on my career, and I'm honored to share a stage with him. He's a sought-after speaker, and we're fortunate to have him here today to share his take on disruption in established high-tech enterprises like yours. Please welcome Jeffrey Moore.
Appreciate it. Thank you.